Okay, the project at hand is to build a new ignition system for Billy Michael's tractor. It's a SpeedX tractor. I think it's a model S23. It's got a cast iron Briggs & Stratton engine in it, and its engine model is a 24434. So what we're going to do is just replace the original ignition system in its entirety. Okay, the concept for the new ignition system is what we've been using for the last 20 years on Tecumseh engines, and we have about 1,300 of these modifications on Tecumsehs, but this is the first one I know of that was going to go on a Briggs tractor. The heart of it is about a mid-80s type Chrysler control module. They're readily available and getting less and less expensive. I get the Chrysler type modules from rockauto.com, and they're just a few dollars. What we do, the module itself, that has the pin connections. Pin A there's no connection for that. Pin B goes off to a trigger, which is on the other side of the engine, and this whole video is about setting up the triggers for it. Pin C is the plus 12 volts from the battery to supply power to the control module. And I might note that if your battery voltage drops below 8 volts, the ignition is going to quit. So you need 12 volts to operate that. Pin D here is a blue wire that goes off to the ignition coil where you would conventionally see the points. So I've just made a little bracket that's conveniently mounted on the front of the engine. This particular tractor has no place to mount anything, so it's no dashboard or anything, so it's hard to do. This is a conventional ignition coil. This one happens to require a ballast resistor, which is back here behind the coil. So generally I prefer to use ignition coils that have a built-in ballast resistor. It makes things a lot simpler and probably cheaper. So that's what the ignition looks like. Okay, this is a trigger coil which we need to install, and to the right of it we have a rare earth magnet that we need to place somewhere. So this trigger coil generates the timing pulse for the control module. This is the original magnet for the magneto, and it covers many degrees of rotation for the flywheel, and it's totally unsuitable for use for a nice point, nice well-defined trigger pulse for the ignition. So what we need to do is stay away from this magnet as far as we can get. Also notice here there's a timing mark on the original magneto bracket here and here. So what I did is I'm going to set this up the way we want the spark timing to be for the running of the engine, and then we will build the new ignition to that point. I should mention that this bracket, I've been very careful to not move it, to not change it, to not discard it or disturb it, because it's a record of the original OEM ignition timing marks. So if you're working with this engine, you'd be wise to leave this thing alone if you want to have a good record of what Briggs & Stratton did for ignition timing. So okay, so we have it set here, so we can set the magnet and the trigger coil just about anywhere we want to As long as they're together, then we should get a spark at this point. So what I have decided is, I noticed that there's a big area behind the flywheel here, and it's somewhat distant from that magnet, which is good, and it's ahead of that magnet in rotation. Rotation is this way. So I think this would be a good place to locate the magnet, right about in here. And I think the trigger coil, we can make it easy for ourselves, and we just mount the trigger coil on the baffle on the back side of the flywheel. So use that as a blessing. Usually a lot of work goes into making the trigger bracket, so this should eliminate a lot of that work. I'm putting my fingers back in here, and I can feel that maybe a good place to locate the trigger would be somewhere like in here. So what I'm going to do is I'm going to make a line across the flywheel and this back cover plate, and that line is going to represent my master ignition alignment marks. So put that here. So what we need to do then, later on with epoxy JB weld, I'll put the magnet here, right back from the edge just a little bit, and then we need to mount the trigger coil so it lines up with that. That would be something like this. So okay, on removing the flywheel, I just backed off the nut with a impact wrench, and I usually try to not remove the nut completely the first time, because it helps keep the flywheel from falling on the ground, maybe damaging it or something. So I'll finish removing that nut when we're done here. This is my handy dandy flywheel puller. This one has got one side for Briggs, the other side is for Kohler. A piece of scrap 2-inch angle iron with a 1/4-inch wall thickness. I put these bolts in here and I tighten them up as tight as I can get them. You know, just tighten it up really as tight. Usually, if you pull the flywheel out like this, because it's got a little in play on it, it does go in and out, and then just wrap this thing here, usually the flywheel just pops right off. There she goes. So that's that. You got to be careful with the older Briggs engines. I think it's the Model A or Model B, maybe a Z, that's got some magneto behind the flywheel, and this place where you put the screw in for removing the flywheel, that screw will go right on through the windings on a magneto and just destroy the magneto if you aren't careful. So on these older engines, check to see what's behind the flywheel sometimes before you pull putting the screw in there. Okay, now we can going to remark the holes, the marks there, and then drill the holes for the triggers. I cleaned up my marks here, added some scribe marks to make them accurate. I drilled some pilot holes, very small pilot holes, to give me an accurate center location for these holes, and then followed it up with a 1/4-inch drill bit. What I did, I'm putting a 1/4-inch bolt in here that I can use to locate the the position of the magnet on the flywheel. I forgot to mention earlier, on the end of these, taking these flywheels off, you know, don't even think about hitting the end of these crankshafts with a hammer, because as soon as you do, the engine figures out you're going to hit it, and it just turns that into that crankshaft into a mushroom, and you'll never get the flywheel off. So don't ever hit the end of this. Okay, looks like I made a little mistake here. I got the bolt location too far outboard, and I'm going to have to either drill a new hole or elongate the hole to a little racetrack pattern to move the bolt further inboard. So much rather be doing all of this and get this done, and then when we come to locating the magnet, it's just a matter of moving it around on the epoxy to get it in the right, exactly the right place. So, but they're gonna have to drill another hole to make that inboard. Okay, so I drilled my new hole here where I should have the first time, and I put a threaded rod in there, and it comes out just short of the flywheel, and then I scribed a mark on the flywheel for the magnet. And of course, before doing that, I set my arrows up here for the timing marks, for the OEM timing marks for the advanced spark. Okay, so here you can see this scratch mark I made going around it. So that should very accurately align the magnet with the center of the pole piece, or the 1/4 inch threaded rod right there. So I'm going to position the magnet there. You can also see a reference line we made in the beginning is fairly close to that. Normally I would say don't drill holes in flywheels, but in this case, this whole section of the flywheel is about the meatiest part of the whole flywheel. There are no other holes or notches or cutouts there, so I'm very comfortable, and I'm going to drill a hole about half the depth of the magnet so that I can set the magnet in a little pocket. I think that'll make sure that the magnet is secure, much more so than if we just put it on the surface. Okay, it turns out that I have a Briggs & Stratton engine simulator that we're going to deal with later at the end of the video clip, but it has also a 10 horsepower cast iron Briggs engine. The flywheel on that particular engine has a ring gear on it for a starter motor, and it also has a ring of magnets on it for the stator, for the alternator for charging the battery. So it's a little different configuration. However, it turns out that there's a rivet, a big rivet, where the ring gear is put onto the flywheel right here, close to the same area as where we're going to put the other magnet. So what I'm planning on doing is cleaning this up real good, and while I have the epoxy out, I'm just going to put, for the simulator, the magnet right here. So somebody having a flywheel with a ring gear would probably have to do the same way. That way we don't have to do any drilling at all at that. Okay, here I have put the epoxy in a little pocket that I made, and put the magnet in it. Off in the background you can see a magnet just for comparison of the size of, the relative size of these things. One thing you'll notice is that JB Weld, the epoxy that I used, has iron filings in it, so it's very much attracted to magnets. And when I put the epoxy in the pocket, it proceeds to pull the epoxy up to both sides of the magnet. So it makes a little bit of a mess here for starting with, but in about 2 hours or later, when the epoxy is about halfway or 3/4 set up, I'll clean it off, and it comes off pretty clean and nice. And I'll just take a sharp knife and cut it off the top and make a cut around the base of the unit there, and then just pick off the excess epoxy. This is the magnet for the flywheel for the engine simulator, and you can see that the epoxy was just pulled all over the place by the magnet. But I'll be cleaning this up again in a couple of hours from now, and I might even have to go back and fill in where the epoxy got pulled up out of the hole. So we'll see what happens. This is what the magnets look like after I got them cleaned up. This is just for comparison, sticking on there. Okay, on the flywheel with the ring gear, the magnetic field sucked in a little groove all the way around there. If I were going to put that on a real engine, I'd probably have to want to fill that in. So anyway, we're going to let this continue to set, and tomorrow we'll see if we get a spark out of it. Okay, I made a bracket to mount where the old magneto used to be, and on that I put a terminal strip. So I'm not going to be surprised if we have to make some changes here. So a terminal strip should facilitate that. Right here I have the ground connection. Actually, the battery cable comes over directly to the starter motor whenever I can make it happen that way. And we've got a ground wire going directly from there to this binding post here. And for that, the coils, the trigger coils, are essentially in series. They're wired in series. And starting with the advanced trigger coil, I have a ground connection set. The blue wire goes to the ground connection here. The yellow wire for the advanced coil comes over to this terminal here, and then picks up the blue wire from the starting coil, the retarded one, and the yellow wire for the retarded coil comes over here. It connects to the yellow wire that goes off to terminal B on the control module. So wiring's pretty simple, and I suspect we'll be changing this around a little bit as we go. What we have here is I've installed the trigger coils. When we left off, we were mounting a piece of the iron 1/4" national course thread, section of threaded rod actually, and lo and behold, the magnet lines up very nicely with the threaded rod. On the other threaded rods for the trigger coil, I had to work backwards since the magnet position was already given, and I wound up filing a slot in it, so that didn't nearly go that easy. Then I went off and made the advanced trigger coil and a top dead center trigger coil. Now for the advanced coil, I did not know how many turns of wire to put on it, so I just put a bunch of wire on the bobbin, and we're using the bobbin because it fits in here. There's not a whole lot of space in there, and the dimensions of the bottom are ideal for this. I also think I ran a 1/4" coarse tap through the bottom at one time to thread it. So anyway, I didn't know how many turns of wire to put on it, so I put a bunch of it, ran it on the simulator, and then removed wire until I got down to about 450 RPM. 450 RPM is near the upper end of the range where the starter motor should have the engine beginning to start running. I think the starter motor RPM measured up to 450, 500, something like that. And the battery is not fully charged too. So we have 47 turns of wire on this wire. The polarity is important. So you need to go, I'll have later on I'll show you the winding machine, and there's a convention that I established on that. You need to follow that convention to get the polarity of the coil correctly. If it turns out to be not what we wanted, we could flip the coil over, or we could switch the wires up here. So that's easy. Now I also noted that the magnet on the flywheel, face of the magnet was facing the trigger coil was north. So we had this trigger coil was looking at a north pole of a magnet. So the reason I did that is I just let the magnet find its way to the flywheel where it would hold itself on and not push itself off. So it made life a lot easier for installing the magnet, and probably did a lot better job. So that I just let float. So also I measured the resistance of the advanced coil with the 47 turns, and it turned out to be about 45 ohms. And as I said, we get the first spark from the advanced trigger at 450 RPM, which is way up there as far as kicking the engine back and out. So we should not have any problem with kickback on it. Now, one of the questions was the air gap. Now, there is an issue. The crankshaft has an in-play in it, and that in-play has to be there for the crank journal and the connecting rod to work properly. So we're going to have to live with that. I measured that in-play at 6 thousandths. So my thinking was that if we had 6 thousandths of play in the crankshaft, and we made the air gap 10 times that, say 60 thousandths, then that amount of in-play in the crankshaft should not make any difference. So that allowed me to pick the air gap at 60 thousandths, which is what I used. Okay, what we have here is the ignition is now set up, it's functioning, it's putting out sparks, and what we need to do is to start checking the timing of it. So what I'm going to have to use are these timing marks here. It's got compression. Okay, this is top dead center, and we can use that for the top dead center indication. The OEM timing mark for advance is over here, so we can use this arrow on the flywheel. I've embellished this a little bit with a silver colored magic marker, so that can give us the timing marks that we need for reference. So I'm going to just crank the engine, turn on the ignition, and see what we have for timing. The RPM is probably going to jump up to 600 RPM or above, so it's going to immediately jump to advanced. We can see that this is the advanced timing mark here, this is the advanced timing mark over here. So it is substantially less advanced than it should be. So one of the things I did up front was I measured the polarity of the magnet on the flywheel and the polarity of the magnet on the simulator, because polarity of all these magnetic devices has a definite effect on what we're trying to do. So what I suspect is that we need to make a polarity adjustment to see if we can bring the OEM timing mark closer to the take the actual timing mark closer to the OEM timing mark. So this adjustment is pretty easy to do. All we have to do is switch 2 wires. We're going to switch this blue wire from this ground terminal here to it's connected to be in series with the other trigger up here. So I'm just going to switch those 2 wires. Okay, so I switched the wires on the advanced trigger. The end of winding wire now is connected to the ground, and the beginning of the winding wire is connected to the top dead center trigger coil. So Now we can go back and see what that effect that had on the advanced timing mark. See, now that brought it in really close. Like really close to top dead center. So that looks good. Let me shut that off. Okay, so that brought the timing mark way down to, I think it was just a little bit this one side or the other of the advanced trigger. So I think that's fine. That should pretty much accomplish what we wanted to give us a spark at top dead center above 450 RPM, and the starting spark, which is at top dead center, after about 2 sparks the engine's already ramped up above 450. So that feature gets very little use the first 2 sparks when we start to crank it. Okay, I'm going to put an addendum in here that explains why this shift in spark advance occurs when we switch these wires, but I'm trying to not get too technical here, and I'll push that off to the end. Okay, so the next thing to do here with testing is to turn the gas on and see if the ignition will actually run the engine. So let me do that. I've already turned the gas on. Let's see what happens here. Ignition is on. I have a toggle switch with a pilot light for the ignition, so that I'll turn the ignition on, and a push button switch to pull in the solenoid. The engine starts rather magnificently.